Hello everyone. Today's lesson is going to be about the greatest common factor. What is a greatest common factor? The greatest common factor, or in simple terms, GCF, is the greatest number that is a factor of two or more numbers. Now, how do we find the greatest common factor of two numbers? It's very easy. Using the factor tree to find the prime numbers of each number, and then I'll tell you what you have to do. For example, if we have the number 20, ask yourself what two numbers you multiply together to get 20. We have 2 multiplied by 10, or even if you wrote 4 multiplied by 5, you're going to get the same answer. Now, since 2 is a prime number, I'm going to circle it. 10 is not a prime number yet, and what gives me 10? It's 2 times a 5. 2 is a prime number, 5 is a prime number, so now I'm done. So for 20, the prime factorization or the prime number is 2 times 2 times a 5. Now let's move on to 24. What gives me a 24? It's a 3 times an 8, or 2 times 12, or 4 times 6. It's the same. 3 is a prime number, so I'm going to circle it. 8 is not a prime number. What gives an 8? It's 2 times 4. 2 is a prime number, I circle it. Is 4 a prime number? Of course not, because 2 times 2 is going to be a 4, and the last two 2's are prime. So for 24, it's going to be 2 times a 2 times a 2 times a 3, and that's it. Now you ask yourself, what are the common factors? I have these two, I have these two. Is there anything else? Of course not. So I write that the greatest common factor of the numbers 20 and 24 is going to be, I'm going to just take 1 2 from here and 1 2 from here, so it's 2 multiplied by 2, which is a 4. Then the greatest common factor of 20 and 24 is going to be the number 4. More examples. 16 and 32. What gives a 16? It's 4 times 4, or 2 times 8. Prime numbers? Of course not. 4 can be 2 times 2 multiplied by the second 4 is also 2 times 2. Prime numbers, of course, 2, 2, 2, and 2. Now 32 can be, for example, a 4 times an 8. Is 4 a prime number? Of course not. 4 is 2 times 2. Multiplied by 8 is what? It's 2 times 4. Where are the prime numbers over here? 2, 2, 2. But this 4 can be 2 times 2. So now the prime factorization for 16 is 2 times 2 times 2 times 2. Prime factorization for 32 is 2 times 2 times 2 times 2 times another 2. Now circle the common factors. I have one here, another one here, another one here, another one here. So the greatest common factor of the numbers 16 and 32 is going to be, take 1 2 from these, it's a 2, times 1 2 from these, another 2, times 1 2 from these, it's a 2, times 1 2 from these, it's a 2. 2 times 2 is a 4, 4 times 2 is an 8, 8 times 2 is 16. Okay, notice here that 16 is the greatest common factor because 16 and 32, what's common between them? 16 is a factor of 32 and 32 is a multiple of 16. Now the last example, 18 and 42. 18, it's 2 times 9. 2 is a prime number, so I circle it. 9 is not prime because it's a 3 times 3. These two 3's are prime numbers. Let's go to 42. 42 can be 2 multiplied by 21. Now 2 is prime, but 21 can be a 3 multiplied by 7. 3 is prime, 7 is prime. So 18 is 2 times 3 times 3. 42 is 2 times 3 times 7. Then the greatest common factor of the numbers 18 and 42 is, circle the common factors, 2 and 3. Take one of these 2, multiplied by, take one of these 3. So 2 times 3 is a 6. Then the greatest common factor of the numbers 2 and 3 is going to be a 6. Yes, this is how we find the greatest common factor of two numbers. Thank you so much for listening.